Hi, Math 3 students. Today we are going to go over, continue going over solving rational equations. So I know this is our third day of doing this, so hopefully by now we're feeling pretty decent with this stuff. So we'll go ahead and we'll start here with question 71. The first thing we're going to do is identify our common denominator. Now x squared minus 1 can be factored into x plus 1, x minus 1. That's a difference of squares. Remember, you can take the square root of both of these. You got the minus sign, so that follows the difference of squares factoring pattern. So looking at that factor denominator there, we can see that our common denominator is going to be x plus 1, x minus 1. Now, the multiplied out version of that is x squared minus 1. And again, I am going to use this when I have to multiply both, just because it makes the multiplication easier. So if we look at our first term here, he doesn't have either, so he needs both. So that's why I'm going to use that x squared minus 1. So I'm going to do 1 over 1 times x squared minus 1 all over x squared minus 1. So I get x squared minus 1, excuse me, over x squared minus 1. Now, our next guy here, which is our 5, we've got 5 over x minus 1. So he's missing the x plus 1. All right, and don't forget to distribute. So we get 5x plus 5, all over our common denominator of, and you can multiply it out or leave it factored. It doesn't really matter. These are equivalent terms. I'm just going to do the shorter version because it makes my life easier. And then what it's equal to is already has the common denominator. So we've got 3x plus 7 all over x squared minus 1. All right, so now at this point, we want to set the denominator equal to 0. So if I do x squared minus 1 equals 0, I get x squared equals 1. When you take the square root of both sides, don't forget, you have to add in a plus minus. When you add in the square root symbol, you got to add in a plus minus. So we know that x cannot equal positive or negative 1. All right. So then we can go ahead and at this point, we do have our common denominator across the board. So we can drop that off and actually solve the equation here. So we get x squared minus 1 plus, and you can distribute this plus, but it's the same thing as just combining like terms. 5x plus 5 equals 3x plus 7. Looks like we are going to get a quadratic here. So we get x squared, and then we get plus 5x plus 4 equals 3x plus 7. We got to get this over, get it set equal to 0 because it is a quadratic. So let's see, we end up with x squared plus 2x minus 3 equals 0. So, of course, we need to go through and solve. I would solve by factoring here. So we need to figure out what multiplies to negative 3 and adds to 2. So we will do x plus 3 and x minus 1. So we get x values of negative 3 and positive 1. Now, of course, we got to do our check at the end. Well, what values can x not equal? We said, where did I put this? Here. We said that x cannot be positive or negative 1. So this guy's a bad solution here, and our only good solution here is going to be negative 3. All right. Number 73 is next. So the first thing we want to do here is identify our common denominator. So our common denominator here is going to be x plus 5, x minus 5. All right. So, of course, you could also multiply that out and you would get x squared minus 25. It's important to understand that those are equivalent, right? It's like the factored form, the unfactored form. So if we go ahead, this first guy is missing a x minus 5. Now, don't forget, the denominator, you don't have to multiply out. You could leave it factored. However, the numerator, you have to multiply out. And in this case, we're multiplying two binomials, which means we got a FOIL. So we get x squared minus 5x plus 2x minus 10, all over our common denominator of x plus 5, x minus 5. And we could go a step further and just combine our like terms here. x squared minus 3x minus 10. And I'm going to be lazy and write out the multiplied out version of this, which is x squared minus 25. All right. So now we can go ahead and work on the next term here. So we've got 3 over x minus 5. So this guy is missing the x plus 5. So I'm going to multiply him by x plus 5 all over x plus 5. Now this guy's easier because he's only got one term in the first fraction, so we just have to distribute. And we get 3x plus 15 all over our common denominator of x squared minus 25. And then our last guy here, he's got 3 over x minus 5. So he is also missing the x plus 5. We distribute, we get 3x plus 15. So we can go ahead, x squared minus 25. Now you might have noticed that you, because these are like the same terms, you also could just like end up canceling those out and solve this a completely different way. So if you notice that and you want to do it that way, by all means, it'll work out. But I'm going to continue doing it this way. All right, so we're going to go ahead and figure out what x cannot equal. So if I set my denominator equal to 0, x squared minus 25 equals 0, x squared equals 25. I take the square root, add in plus minus, we get that x cannot equal plus or minus 5. All right. So at this point, I can go ahead and get rid of my denominator and solve for x. So I go ahead and I'm going to get x squared minus 3x minus 10. It's a plus sign, so I get plus 3x plus 15 equals 3x plus 15. So one thing I could literally just do is just cancel these out. Minus 3x minus 3x minus 15 minus 15. Goodbye, goodbye. And we end up with x squared minus 3x minus 10 equals 0. And we can factor this. What multiplies a negative 10 adds a negative 3. That is going to be x minus 5 and x plus 2. So when we set that equal to 0, we get that x is 5 and x is negative 2. Of course, we got to go check our answers. 5 is bad, right? So our only good answer here is negative 2. All right, let's go ahead and try number 75 here. So again, we have to look and figure out what our common denominator is going to be here. So what I'm going to recommend doing is factoring this guy to give us kind of a sense of what we're working with. So it multiplies a negative 32, adds a negative 4. Let's see, x minus 8 and x plus 4. So by the looks of it, that's going to be our common denominator. And again, we could leave that multiplied out as well. These are equivalent. All right. So this first guy here is missing the entire thing. So instead of doing like, and I'm going to explain to you why I use this. To me, I feel like this just seems like if I like more work, right? Like instead of doing like 1 times x minus 8, times x plus 4 over x minus 8 times x plus 4. To me, this just looks like a lot of work. Personally, I know what this is when I multiply out those two binomials, so that's what I'm going to multiply the 1 by, which is just x squared minus 4x minus 32. It just feels like less work to me. If you'd like to multiply by the binomials, though, by all means, that is fine. And really, we're just distributing a 1. So we just end up with our x squared minus 4x minus 32 over x squared minus 4x minus 32. Now, don't forget we've got a subtraction sign here. And my middle term is, we've got 2x plus 7, x plus 4. So he's missing the x minus 8. So we're going to go ahead and do x minus 8, x minus 8. Now, this is a foiling one, right? We've got a binomial times a binomial on top. So we got to FOIL that stuff out. So we're going to end up with 2x squared minus 16x plus 7x minus 56. All right, and then that's all over. And again, we know if we multiply this out, we get that. So that's what I'm going to write. We get x squared minus 4x minus 32. I do want to combine like terms here. So we know we can rewrite this as minus 2x squared and then minus 9x minus 56. X squared minus 4x minus 32. All right, and then this guy's good to go, right? He's got the common denominator. We don't got to do anything with him. So we get x plus 3 all over our common denominator of x squared minus 4x minus 32. Oof, this is a lot of work, huh? Luckily for you, I cut these. I'm only doing half the problem, so you're welcome. All right. So now we can go ahead. We got our common denominator all across the board. Let's figure out what x cannot equal. So we'll take our factored form of the denominator, x minus 8 and x plus 4, set that equal to 0. We get that x cannot equal 8 and x cannot equal negative 4. So then we got to go through and actually solve this. So we get x squared minus 4x minus 32. Don't forget to distribute this negative. Everyone's still struggling with that. You have to make sure if it's a minus sign, you got to distribute it to everything. So we get minus 2x squared plus 9x plus 56 equals x plus 3. So I'm going to combine like terms. I get negative x squared plus 5x. And then I'm going to use my calculator because it's getting late. So 56 minus 32. And I got 24. Equals x plus 3 minus x minus 3. Actually, you know, I'm going to move everything over to the other side here. And the reason I'm going to do that is I don't like having this negative in front of this x squared. So to get rid of that, I'm going to move all of this stuff over to this side of the equation, just because I like that better. So let's add x squared. So he's going to be by himself. We're going to subtract 5x. And we're going to subtract 24. So we get 0 equals x squared minus 4x minus 21. All right. So we can go ahead and solve by factoring. We're going to factor this guy into x minus 7, x plus 3. We get that x is 7 and x is negative 3. So we got to look, okay, what can x not equal? It can't be 8 and it can't be negative 4. Both of these are good solutions. So our answer here is going to be 7 and 3. All right. All right, guys, we are on our last problem here. I will say I did not give you guys enough space to do this problem, so I apologize. You can do it on a separate sheet of paper if you need to. All right, so first we got to look, see if we can get our common denominator here. So this first guy here, hopefully you noticed this pattern where it's like this, the opposite of everything else. So let's deal with that first. We know that we can take a negative out of there, and we get negative 9 plus x, which we can write as negative x minus 9. So when I do that, I get 2x plus 5 all over negative x minus 9. Now, a lot of you guys, what you've been doing is just like rewriting the negative on top like that, but that doesn't work in this situation. You have to make sure that you do what I taught you, where you do like the negative 1, because you have to distribute that negative 1. So then these negatives cancel, and we are left with negative 2x minus 5 all over x minus 9. Okay, so now kind of looking at the different fractions that we have, we can determine what our common denominator is going to be, which in this case, our common denominator is going to be x plus 9 and x minus 9. All right, so let's take a look at our first guy and work on getting him the common denominator. So we've got 3x plus 7. And then he is missing the x minus 9. All right. So unfortunately, we got a FOIL. We're going to get 3x squared minus 27x plus 7x minus 63. All right. So we get 3x squared minus 20x minus 63. So he is good to go down here, 3x squared minus 20x minus 63, all over our common denominator. of x plus 9, x minus 9. Now, if you want to FOIL out the denominator, you totally can. You get x squared plus x squared minus 81. Feel free to do that. All right, so now our next guy here is missing the x plus 9, right? So we're going to multiply him, FOIL him out. So we get a minus 2x squared minus 18x minus 5x minus 45. So we end up with a minus 20, no, not minus 20, minus 2x squared minus 23x minus 45, all over our common denominator of x plus 9, x minus 9. And then our last guy here, he is missing the x plus 9. So we've got 5 all over x minus 9. So we're going to do x plus 9 over x plus 9. Now, fortunately, he just needs to be distributed. Makes our life a little bit easier. So we get 5x plus 45, all of our common denominator of x minus 9, x plus 9. So at this point, what we can do is we can look and say, okay, what values of x are not going to work here? So we can go ahead and say that x cannot be 9 and x cannot be negative 9, right? Because if you set these equal to 0, you get those x values. So now we can go ahead and drop out our denominator and actually solve this quadratic. So we end up with 3x squared minus 20x minus 63 minus 2x squared minus 23 minus 45 equals 5x plus 45 gross. So now let's go ahead. We're going to combine like terms on the left-hand side here. So we get x squared. Then we get this guy and this guy gives me a minus 43x. And then this guy and this guy are going to give me, let's see, negative 63 minus 45 gives me a negative 108. And then this is equal to this 5x plus 45. So now it's a quadratic, so of course we want to get everything on the same side. So we're going to do minus 5x, and then we're going to do minus 45. Minus 45. So we get x squared minus 48x, and then negative 108 minus 45 gives us negative 153. All right. Now, this one's tricky. I'm not going to lie to you. You can factor this, but if you get something like this where it's hard to factor and you can't figure it out, please remember, any quadratic, you can use quadratic formula. So if you get to this and you're like, dude, I got no idea how to factor this, you can go ahead and use quadratic formula. However, I am going to factor this because I know how. So I believe 51's a factor of this. Yeah. So my two numbers here are going to be what? Negative 51 and positive 3. So I'm going to do x minus 51, x plus 3. I get that x is 51 and x is negative 3. And then I have to, of course, go and check to see if these answers are good. X cannot be 9 and negative 9, so these are both valid answers.